Good morning, good afternoon, or good evening from wherever you are. I'm Ed Kohler with Avaya, and I'm here to talk with you today about deploying fabrics into existing network infrastructures. Now, this might seem off base to some of the previous videos that I've been posting on my channel, but I've had a number of conversations as of late with folks that have seen my videos or read my blogs and have said, "Wow, Ed, that's really great. I'd like to do that, but I don't have the kind of CapEx in my budget in order to swing this kind of technology investment." And I've been spending a lot of time as of late meeting with customers and talking about hybrid approaches, about deploying Fabric in a phased fashion, doing it in a fashion that addresses pain points and requirements without the need to do a full rip of the infrastructure. Seeing as I was having so many meetings on this subject, it made sense to me to create a video along this subject matter. Now, other colleagues of mine have been dealing with the same issues. Some of the slides that you're going to see are from a very good colleague of mine and a good friend by the name of Roger Lapou. And he has created these particular images for our latest Avaya technology forum. What I've done is I've taken those slides and I've kind of retrofitted them to fit more into a web-based session rather than a lengthy design meeting. So let's move forward. But before we begin, it's always best to look at the challenges that we have today. In traditional IP networks, when you look at enabling network connectivity, it's certainly not seen as a service delivery. It's more like a pipe. You get service delivery as a secondary IT effort. Many SDN solutions are looking to bridge that gap, but really when you look at it, this is still a drastic dichotomy that we see. And the end goal is to actually have the network connectivity be the service delivery. And that's to a large degree what we've attained with SDN Fx. Today's networks are typically flat, and this is not only something that is common, but it's also common in supposedly secure network infrastructures. And delivering network segmentation is not very straightforward. In contrast to that, virtualization is also a challenge. And you might say, well, wait a minute, if the network's flat, virtualization should be relatively easy. But the point is virtualization often requires segmentation. As a matter of fact, if you look at most virtualization architectures, they are about segmentation. And consequently, this is how we start to see a lot of overlays being created in the industry as we see it today. So many folks are grappling with that, and many vendors are creating alternate ways to do it. Again, SDNFX can address these types of situations relatively straightforward. Security. Firewalling is basically the main interpretation of what that is. And it's really morphed now into firewalling and encryption, which is actually an ideal formula for an advanced persistent threat when you think about it. Making it worse, we're often forcing these devices to enforce the segmentation between communities, and that's not the role they were intended to architect for. They were intended to police communication between those segments, not necessarily to enforce the segmentation themselves. Optimally, you look at some other technology to accomplish that end goal. Provisioning of the network takes too long, and this is because we're dealing with complex legacy protocols, and while we're talking about legacy protocols, we often still require spanning tree in these topologies, and it's known to be problematic. Enabling stretched data center solutions for virtual machine migrations, this ability to get universal mobility, that's a big challenge. And in tandem to that, almost directly related from a technical perspective, is the aspect of wireless roaming. The ability for an endpoint to roam seamlessly across the network is a big challenge as well. And finally, we have the Internet of Things. And along with that, IPv6. Now, many folks will say IPv6, that's still way out on the horizon, and maybe that is the case. However, IoT is not. IoT is happening now. We're starting to see that with video surveillance networks, video sensor networks of all types, entry-exit systems for building management systems. All of these things require communication. Many folks are using discrete air-gap networks to approach this. And video surveillance is typically one of those cases, but building infrastructure, so forth, so on. Now, the NSA and others, including myself, have proven that air gaps are less than perfect from a security perspective. They can be very stealthily interceded into, and it's very difficult to know where that penetration has occurred. So air gaps are not absolute. And so when you look at it with a discrete air gap approach, you're duplicating your CapEx, you're creating a shadow IT because you have to have an organization to manage that infrastructure. You also have the complexities of security for that separate infrastructure. And then finally, at the end of the day, it more or less doubles your OpEx. And it's a less than perfect approach. So why are we doing it? And the question you have to look in the long term is, could you approach the Internet of Things that way? Could you create an air-gap network for every single discrete IoT infrastructure you have? That certainly does not make sense or scale in the longer term. So SDN Fx, Avaya's SDN Fx, based on Fabric Connect, which is, again, based on an IEEE standard of shortest path bridging, is based on really three main pillars. The first pillar is network flexibility, the concept of network elasticity, the ability for me to extend a zone out and then track back if required. Particularly if someone logs off of the system. But the reality of it is we can create ecosystems where we can retract the service based on some sort of malicious activity or suspicious activity. We can also manipulate paths to do a high degree of honeypotting, things of that nature. And this is in concert with identity engines so that we can get a mapping of the actual end users and the devices within the network. Remember, the IoT will often have devices which have no user construct associated with them whatsoever. This, again, leads down to the concept of network simplicity, because now we're taking a common paradigm, a common policy base, and this allows us to automate the BYOD, which is typically a device user combination, and the IoT, which is typically a device with no user associated whatsoever. If it is associated, if a user is associated, it's a very transient type of basis, and the ability to onboard those devices effectively with proper policies. And this again leads over to the third pillar of network security, controlling who gets access or what gets access from where and with what. And that's where Identity Engines really provides a very strong role with SDN Fx Fabric Connect. And this all leads to the concept of a user and IT experience. First of all, the fact of the user enjoying the aspect of seamless capabilities, and then finally the IT experience, the ability to manage a converged infrastructure without gaining gray hair. Now, that bar may seem high, and this is the primary conversation I have with many customers, but I tell them, consider the options that lie ahead of you if you choose to do IoT in the traditional network architecture. You're going to be dealing with complex layered protocols. You're going to be dealing with mutual top-down dependence in those protocol architectures. You're going to be assuming a very high operational cost because everything you're doing with the IT, you're basically be going to doing towards a 2x or even a 3x operational model in order to incorporate an IoT model. Remember, some of these elements can be incredibly dynamic and can actually be fairly mobile. So this actually starts to point to some very, very strong shifts in the OpEx, CapEx investment cycle that needs to occur in order to take these traditional protocols into an IoT model. And then finally, we have very high-end networking computation resource requirements because, you know, at the end of the day, many vendors are saying, you know what, yeah, that's a complex mountain range of protocols, but you know what, we can make it all better. We can provide this overlay. We can provide this SDN environment where we can provide the ability to service chain these different protocols. And yes, you can. But at the end of the day, the elements that are running these protocols don't go away. They still require those high-end resource requirements. And also, we actually have the ability for high probability of errors within the human input. And this is another issue. When something does go wrong, the complexities underneath don't go away. We have to go into those protocols. We have to figure out exactly what's going on. So all of the higher level glue that we do in the initial provisioning, if it's done in error at the outset, or if there's some underlying infrastructure error that causes that, a lot of work has to be done in order to tease out what those underlying causes are. As a result, the security model can be difficult, can be complex, and SDN can even mask things so that perhaps there are holes, there are vulnerabilities and exploitabilities that may lie underneath that SDN basically has covered up. So we have to look at it in a multidimensional fashion. When you start to look at moving to the IoT model, it's going to require a rethinking of exactly what networking is all about, realizing that looming on the horizon are the advanced persistent threats. those entities that are realizing that the IoT is putting critical systems onto this network infrastructure. And if they watch long enough and they wait long enough and they're stealthy in the way they actually leverage on these vulnerabilities, they will eventually get in. And the reason why is because of the complexities of what we're dealing with. So many folks are saying, wow, Ed, the story of Fabric Connect and SDN Fx, that's great. But man, what a gap. To get down from this range down to that, I've got to really make some major shifts. There has to be a way to bridge the gap. And indeed there is. This is really what this webcast is all about. SDNFX allows an enterprise to actually take a different shift in mentality. They can now look at themselves as an enterprise service provider network. And the following slides are going to kind of pick that mentality. And it's all based on initializing and recognizing certain pain points or needs within the IT organization that need to be met. The whole point is that we can start with a phased approach, and we can do this in various levels of scale, from single switch all the way up to multi-site enterprise deployment. We're going to try to show a features benefits for each phase, and we're going to show, or hopefully show, the focus of each type of phase and what it's trying to accomplish. But we're not going to come up with dozens and dozens of protocols or 3 or 4 different architectures. We're going to use one architecture and we're going to use 3 technologies. SDNFX is the overall architecture, and you're going to see the use of 3 technologies within that portfolio. Fabric Connect, based on shortest path bridging. Fabric Extend, which is the ability to actually have automatic attachment and the ability for those zones, which are based on Fabric Connect, to be able to communicate over traditional IP infrastructures or L2 infrastructures. In other words, the ability to stretch or extend the fabric over those zones. And then finally, Fabric Attach, the ability for automatic attachment of end stations. And those may be IoT type components. So we're going to talk about these 3 technologies in various scopes. And as you're going to see, there's quite a broad palette of options that can be offered with just these 3 technologies. Now, I want to emphasize that interconnectivity options are divided into 2 categories. We can take SDNFX and we can connect them to legacy networks seamlessly. And by connecting, we're talking about using peering technology, either L2 peering, VLAN tags, things of that nature, or even L3 peering, such as route redistribution, so forth, so on. Second avenue is we can also operate as overlays, so we can run on top of legacy networks. And if we do that, we can actually keep a ships in the night perspective. Often, for migration purposes, these 2 approaches are used in tandem with one another. So you can overlay a fabric and then interconnect it back to the original network so that you have end-to-end seamless connectivity. And probably you're doing that through some sort of security demarcation point. The whole issue here, and the whole point I want to have in this slide, is that whole infrastructure RIPs are not a replacement. A network can introduce fabric to address a pain point and then evolve to an end-to-end fabric over time. Now, in order to really go further in the dialogue, we need to look at the tools involved. So the first set of tools we have are the layer 2 peering methods, and this is basically the good old-fashioned IEEE 802.1q VLAN tagging. And as you can see, we can operate with all of the multi-link and link aggregation methods that are prevalent in the industry today. And this provides a very good way for seamless peering to a traditional L3 edge to a Fabric Connect core. And this is one of the preferential methods that a lot of folks deploy the Fabric in, because it is very simple and it's very open. You can have any vendor hanging at the third-party edge and you get complete interoperability across the infrastructure. There is also the ability to do a layer 3 unicast peering, and this is a second mode of interconnectivity options, and this is where we're obviously using VLAN mapping, but we're also using static routing, and perhaps the ability to map between ISIS to static routing, RIP, RIP-NG, OSPF v2, v3, BGP, most of the protocols that you're going to run into the industry. Obviously, we want proper route redistribution with accept policies and external metrics, and this gives very granular control for what you're going to allow to interconnect between these different domains. So it gives a very good option not only for, static interconnectivity, but really primarily when you're doing migrations. This is a very handy tool because now I can take portions of the network, bring them over to the fabric, and still maintain seamless connectivity as the migration is occurring over time. We also have the ability to do peering with IPv4 multicast, and this is a specific type of peering. Typically in the past, what we've done is we've accomplished it through static multicast receivers, and that works really well. However, obviously, due to the fact that it's static, it's not very dynamic, and also it has issues of scale because of its static nature. Eminent is VOS 6.0, where we'll actually have a full SPV PIM gateway functionality for dynamic interconnection of PIM with Fabric Connect. Now, this may be for purposes of migration where you're saying, okay, I've got an existing network and I'm using PIM as an active application support model and I need to migrate over time. We can certainly facilitate that with the use of this gateway. But we also find that many firms, state agencies, universities, things of that nature that have moved over to Fabric still need to interface with PIM domains. So you could think of the PIM gateway as actually being a permanent infrastructure if it needed to be as such. In any event, VOS 6.0 will provide for this feature functionality. And then finally, the secondary category that we talked about, the ability to overlay the fabric on existing infrastructures. And this becomes a very key tenet, and it's really the primary facet of Fabric Extend. I want to emphasize that this can happen through a number of fashions. This can happen through dedicated L2 paths, where we can almost run the NNIs natively, or over dedicated tagged infrastructures, or we can actually do an IP encapsulation, so we can run over any IP WAN MAN type of network infrastructure. So there's multiple ways that this overlay can occur. Now, to talk about these scenarios, we're going to start with a single switch, and then we're going to move forward with varying degrees of complexity until we get to the large multi-site network. I want to emphasize two things. You're going to find these slides to be repetitive, so I'm going to move quicker and quicker as we move through the presentation, only talking about the unique attributes of each slide. And then finally, when we get to the large multi-site network, I'm going to start talking about Fabric Extend. I don't want people to think that they have to wait to be a large multi-site enterprise network to think about using Fabric Extend. They work well in the 4-tier, the 3-tier, the 2-tier network infrastructure. They also work well with smaller companies that may have a very large geographical footprint and require a provider to get that reach. So I just want to emphasize the fact that you're kind of saving that towards the end in the design type of options, but it's not necessarily dedicated to a large Fortune 500 type enterprise. Okay, so the first thing we look at is a single switch, and many folks will say Fabric in a single switch. What sense does that make? Well, I have a little story, but before we talk about that story, let's talk about the benefits. First of all, one of the hidden things you get is VLAN translation. I can take VLAN 10 in and ingest VLAN 100 in, and I can create a single L2 domain. VLAN 10, VLAN 100, there's single one L2 domain. Handy little feature. You also have seamless L3 services, and I get that without starting up OSPF. I start the fabric, I start IP, and basically I'm routing. Again, that is in concert to seamless IP multicast. That's all I do is enable multicast, and I have that capability. Now, here's the story in tandem to this. There was a public provider, actually it was a county out in the West, and they were having issues with video surveillance. They were having issues with their intelligent traffic management system. And it was basically because of a dogfight that was happening at the network. We took out the 3 competitive switches that were there. There were third-party core switches that were running PIM, Protocol Independent Multicasting. We took those 3 switches out. We put one switch in as a loaner running the fabric. And they immediately stopped seeing outages in both systems. They have since given us back the loaner, they have since put in an infrastructure and have moved forward with Fabric. But the point is one switch can make a difference, and that actual story proved it out. Let's take a look at a simple two-tier design. This might be your typical small, medium business, and let's look at the nirvana. Let's say they just say, okay, I'm biting the bullet, I'm going to put Fabric into end-to-end. Well, when you look at that, you get a number of benefits. You replace spanning tree. Spanning tree goes away. You get edge provisioning only. You're no longer dealing with VLANs across the core or routed interfaces in the core. I have seamless wireless LAN roaming using Fabric Attach and the ability for individuals to move across my campus without the ability for tunneling or any other complex type of technologies underneath. On the data center side, I've got server integration and simplification with things like OVS, Linux hypervisors, and VMware. I also can support seamless vMotion. I can support end-to-end network segmentation, virtualization environments, where I can actually start to support domains to support PCI, HIPAA, things of that nature. And I also get the resiliency, very, very high degree of resiliency with less than 200 milliseconds recovery time. And that sub-second recovery time is very key for things like seamless IP multicast and the scale that we can offer with the Fabric. And then finally, you are IoT ready with this type of an approach. But let's say we don't have the pocketbook to do that, and we need to choose a pain point. Well, one area where we might look at is the user access. We might say that, look, I really want to get spanning tree out of the network at the edge. It's a pain in the neck. I want to get rid of it. I also want to get to the point where I'm edge provisioning only. I don't want to deal with VLANs or routed interfaces in the core anymore. I want everything to be seamless and integrated. I also want wireless seamless roaming, and this allows the ability for individuals to move across the network infrastructure in a totally seamless fashion and maintain connectivity to all services. Plus, I get the benefits of network segmentation and virtualization enablement, again giving me those secure segments for PCI, HIPAA, so forth, so on. Note how the data center access TOR has stayed legacy. Okay, I'm leveraging on the good old-fashioned IEEE standards to provide the interfaces, and I can even leverage on route redistribution if required. Option 2 takes more of a data center focus. Maybe the users are fine as they are, and really what I need to do is get key control of my data center assets. I need to get seamless vMotion. I need to get that layer 2 stretch segment capability, and I want to do it without tromboning, without the ability to hairpin between data centers. All of this can be offered by bringing in the Fabric. And then obviously I get this very highly resilient multipathing failover for active data centers. So this is a different focus, a different way I can introduce. But notice that I'm still using the same connectivity options to connect my core out to the user communities. I'm just using, VIST, MC-leg combinations, and that stands for virtual IST, which just basically is a head end for the lags. And I can use route redistribution. I can use whatever methods required in order to provide that gluing to the legacy edge. And then finally, I can look at an option for a 3-tier network design where I've deployed Fabric end-to-end. And as you can see, this is a replication of what we've seen with the 2-tier model. Okay, I get all of the benefits of the Fabric, and I am set up and ready for IoT as I move forward. But again, in a repetitive fashion, I can take a different approach. And as we look at a 4-tier network, many customers are looking to deploy Fabric as a core technology. And this can be done with a 2-tier or with a 3-tier model additionally as well. What do I get by that? Well, here is the concept of where I'm actually providing a provider infrastructure service. I can offer layer 2 transparent services. I can offer switched layer 2 services. I can offer E-tree type of topologies to enforce hub and spoke behaviors. I can offer L3 routed services, IPVPN services, integrated multicast within all of these services. Service enabling, the ability to eliminate VLANs and routed interfaces within the core, giving me very dynamic capabilities. And then finally, I get the core segmentation, the virtualization enablement, so I can actually start to approach a multi-tenant architecture. I get high resiliency within the Fabric, obviously, 200 millisecond or less failover, and I am IoT ready. Now I can start to extend the Fabric further according to what I need, whether it's in the data center or whether it's in the user access. Let's say it's the user access that we need to approach first. Well, I get the benefits of getting spanning tree out of the picture. I can remove my edge provisioning requirements, I get seamless WLAN roaming, and I remove all my routed interfaces and VLANs from the core. I accomplish the need for end-to-end network segmentation, and notice how my data center spine and my data center access leaf are still in the legacy mode. We're using nothing more than route redistribution and tagging in order to glue these worlds together. Option 3, more of a data center focus. This is where we're saying, hey, I've made a lot of money investment into the data center. I want to reach towards the L2 segment stretch for seamless vMotion. I want to avoid the tromboning that I get when I do these vMotions, particularly for longer range and longer time frames. I want to get integration within my hypervisor environment. These are all rationales for making the investment, but notice that the same types of technology, either VLAN tagging or route redistribution, are providing the connectivity back into the legacy environments. And then obviously we have the end-to-end fabric approach, and as you can see, whether I go from the data center in or whether I go from the user access in or from the core out, I can accomplish this goal in a very eloquent phased fashion. Now let's start to talk about the large enterprise network, and I want to say large geographically. You don't have to be a big company, you just have to have a big footprint. So many retail outlets, many banks, many things of that nature may look at this and say, okay, this fits. And many banks are very large, but many banks are not large from a corporate perspective, but have very large regional footprints. Well, the ability to take the fabric and extend it over the network becomes a very powerful thing. So in this area, we're taking the same paradigm, the user access focus or the data center focus, and we're going to bring in the ability to overlay as a different set of design metrics that we can bring in. So here we see two islands where we have two different sites where we've made investment into the core campus infrastructure and the user edge, providing fabric at these sites. Now we're taking Fabric Extend and we're actually tunneling and creating virtual network-to-network interfaces to actually create an end-to-end fabric so that while we have this L2 IP network in the middle, in reality it is an end-to-end seamless network fabric. I get the benefits of spanning tree replacement, I get edge provisioning only, I don't have to touch VLANs in the cores of these different sites. I get seamless WLAN roaming, so user A goes from seeing site A to site B. Guess what? They basically have their same IP personality, their same IP address. There's no reason to do any wacky L3 tunneling, and there's no need to be able to go back to a secure controller in order for that translation, so forth, so on. All of this happens in a seamless fashion because of the direct integration with our seamless wireless capability with SDN Fx Fabric Connect. I get the campus network segmentations, and I can actually drive different secure segments between these sites that are actually islands and ships in the night if I choose them to be as such. And this also gives me the ability for IoT readiness. So at these different sites where I have Fabric installed, now I can start to deploy an IoT framework, and I don't have to deal with a whole series of air-gap type networks to accomplish that end goal. Option 2, this is basically where we're creating a distribution layer focus. And many customers use this. They basically say, look, I've got a series of sites and I want to interconnect them with Fabric, but I don't want to replace everything at each site. I'm just going to get a touch point for the fabric. And here we see that we're actually instituting a distribution approach where I have distribution at each touch point, both the data centers and the user access sites. Now I can interconnect the fabric over the actual Fabric Extend protocol, run all of my integrated services. I get the value of becoming an infrastructure provider in the ability to offer granular services that I would be struggling to do otherwise. And then finally, I don't have to replace the whole infrastructure. I've got touch points into each site with the fabric, and then each site remains largely legacy infrastructure. And I leverage on those connectivity options that we talked about earlier in order to accomplish those goals. Keep in mind that we are now IoT ready, even though we don't have Fabric everywhere, because now I can start to extend Fabric on a project basis according to the demands and the requirements. Option 3 takes more of a user access focus. Note how I still have my touch points to the data centers. I still have Fabric there, and now I'm drawing the fabric across. I'm providing core technology at each major site with seamless wireless capabilities, seamless end-to-end network segmentation, and the ability for seamless multicast. Now with a short extension to my IT budget, which is basically taking that footprint and then extending it into each of these sites, I am now fully IoT ready, and I can start to deliver seamless IP multicast without the need to run PIM as a protocol, for instance. I get the side benefit of seamless WLAN roaming in a very secure fashion using Fabric Attach as well. And again, those end-to-end network segmentation capabilities come back and pay back 3 or 4-fold. Finally, we can look at an end-to-end fabric over the IP man WAN. Now, I want to emphasize that this is exactly equivalent to what you saw earlier, where an enterprise said, look, I'm going to deploy Fabric end-to-end. Even though I have this network in the middle that's layer 2 or IP, I actually have the ability for end-to-end services capabilities. So all of the benefits that you saw earlier for a full end-to-end fabric are realized here using Fabric Extend as the glue to create this end-to-end fabric cohesive domain. Now, once we do that, I can start to extend different domains of interest. I can actually start to have one leg convert to pure end-to-end fabric. So you can envision one half of this topology diagram actually creating fabric end-to-end natively across the infrastructure. Maybe the customer invests into dark fiber for certain data center interconnects so that maybe the data centers will be directly connected by Fabric in the future and not use Fabric Extend. And then I can use Fabric Extend to provide my distribution and access out to the remote sites. That is a very common type of hybrid deployment scenario where someone will evolve over time. We can also approach in a very discrete fashion. Let's say we have a data center issue and primary pain points are seamless vMotion, and I need to get integration with the Linux hypervisors or with some sort of hypervisor environment such as VMware. At that point in time, I really am looking at L2 and IP segments stretch. I need to get the stretch between the domains. Fabric Extend can easily work in this scenario where I can take Fabric-enabled data center top-of-rack switches. So then I can take Fabric Extend and I can use it to link between the different environments. And that becomes a very powerful combination because now I can get the stretched data center environment. I can do the tromboning avoidance for data center gateway redundancy and resiliency. And I can do it and maintain high degrees of network segmentation across this path. So I get a number of benefits, but as you can see, the capital investment required to make that step is fairly small. I'm really just investing into the top of rack and then using Fabric Extend to glue the fabric end to end. I can then say, okay, maybe I want to move a little further and actually start to do a data center spine investment. And as you can see, I start to get a good degree of control. I start to have the ability to extend my segments in a much granular fashion across the data center environment. And then finally, I can move towards end-to-end fabric in the end goal. And I want to emphasize this is the exact same equivalent to what you may have seen in the previous dialogue where we showed the distributed large enterprise environment. Note how this provides all of the benefits that the end goal does as well. The benefits here in the middle at this end vision is I have discrete dedicated NNIs across the whole network infrastructure, which gives me a very deterministic type of network with no underlying dependence on IP or L2 third-party transports. So let's take a look at the checklist here. Enabling network connectivity is not seen as service delivery. That's certainly not the case with what we can do with SDN Fx. We can do secure services extension on a very dynamic basis and a very dedicated basis. Networks typically flat. That's definitely not what we're about. SDN Fx is all about microsegmentation and all about driving those microsegmentations from the data center across to the user. Security, firewalling. These approaches are becoming antiquated, and I don't want to say firewalls have no use. They are very critical elements, but they need to be used in a proper cohesive fashion. They need to be used for what they were intended to be used for and not to be relegated into a segmentation enforcement role. They are intended to be policing communications for intersegment communications. Finally, network connectivity taking too long, that goes away very easily with SDN Fx with our automation, Fabric Attach, and our automated provisioning of end users, our portal usage, things of that nature. Layer 2 topologies using spanning tree, we take spanning tree totally out of the mix. Enabling stretched data centers, very easy thing, and as you can see, we can address some fairly capital expenditure tight type projects to accomplish that end goal with simple investment into the top of rack and then using Fabric Extend. Enabling seamless wireless roaming being a big challenge, we can take that off the table very quickly, and again, the Fabric is very key to that capability. IoT, IPv6, again, very easy. And even though the train for IPv6 may be out there in the distance, we all know that IoT is happening now, and it's happening in each of our enterprises. And then finally, this use of discrete air-gapped networks to provide IoT approach, the ability to handle parallel infrastructures. It's an antiquated notion. It's less than perfect. It's very costly. And at the end of the day, it's going to create security holes. So why are we doing it? Well, the answer is we don't have to with SDN Fx. So as you can see, you can actually introduce the Fabric and have it be deployed for pain point projects as they're required. And then as your capital budget allows, you can deploy Fabric over time. And perhaps there are different projects that you may put on the list. Perhaps today you need to deal with video surveillance. Perhaps tomorrow you're dealing with compliance for PCI. Perhaps the next day you're dealing with real-time communication. Perhaps as these projects evolve over time, you can actually plan out your IT investments so that you can start to deploy Fabric within your infrastructure to do the support of these upcoming next-generation projects. So we don't have to wait. We can start to deploy Fabric now. We can use it to address our pain point projects, and each deployment option has roads for future expansion and a road to the future. Thank you very much for your time. I hope you found this session useful. If you need to talk further about these hybrid approaches, feel free to reach out to your local sales reps or your local SEs for Avaya. They will be happy to go through this with you in further detail, and if needed, we can bring in any expert we need in order to answer your questions. Thanks for your time. Have a pleasant day.